Hey guys, Miss Murray here. It's so nice to see you in person. Maybe you wanted to see me, but here I am. I just wanted to tell you guys I'm super proud of you as a whole. Y'all have brought your averages up, you were on task, and I'm super proud of you. So this week you were dealing with kinetic energy, which is energy of motion or movement. And so I had a few things I wanted to go over with you with kinetic energy. So I'm going to turn my camera around. So here's the paper. I hope you can see it. Get my camera straight. Alright, so remember, you're going to learn, that's okay, let's just erase it, start over. Kinetic energy, let me see if I can get it clear. There we go. Kinetic energy is equal to 1/2 of the mass times the velocity squared. Okay? It's really important that you know that kinetic energy is an energy unit, and that's going to be in joule, and I'm going to speak of it in just a second. 1/2 is just a number. Mass is going to be in kilogram times your velocity, which is measured in meters per second squared. Okay, so I just wanted to show you that this is where the unit for joule comes from. Your unit for joule, 1 joule, is kilogram times meter per second squared. That is the unit for joule, which is an energy source unit. And it comes from this formula right here in kinetic energy for kinetic energy. You also use joule in other things such as work, and a few, I think there's 5 total that you would use joule as a unit in. Okay, one thing I want to show you is the connection between mass and volume for kinetic energy. Okay, if we were to plug in just some numbers, let's say just some generic numbers like 1 for, let's go with mass first. So let's keep mass at 1 and let's make our velocity 1. In this case, when you square 1, you still get 1. 1 times 1 is 1, times 1/2 is 0.5 joule. Okay, so that's pretty easy, just filling in, subbing in the information. If we change the velocity to 2, I want you to think about what might happen. The formula is not changing other than what we plugged in for velocity. So if we plug 2 in for our velocity, 2 times 2 is 4, and basically times 1/2 is going to give us 2. So as you can tell, if we increase our velocity, then the kinetic energy also increases. On the flip side of that, if we put in 1 for our velocity and change our mass, so let's do that. We're going to keep our velocity now at 1. We're going to put mass as 1. We still get the same answer as we got a while ago, which is 0.5 joule. And again, if we change the mass to 2 and keep our velocity the same squared, then we also get an increase, and it's going to be 1 joule. So I just want to show you how important mass and velocity is to kinetic energy, as you can tell from the formula. If you increase either of these, then you're also going to increase kinetic energy. So for example, if we were looking at kinetic energies of, let's say, I don't know, something small like a tennis ball versus something heavier like a bowling ball, which one is going to have the higher kinetic energy? Between a tennis ball and a bowling ball, if we were dealing with mass, the difference is the bowling ball would have a higher kinetic energy because of its mass. So maybe this clears up just a little bit prior to you getting started in the lesson. It was good seeing you and talking to you, and if you have any questions, feel free to get with me. Have a great week.